We are in section 9.2, two means independent samples. In this test, we collect two independent samples to test whether there is a difference in the means between the two populations, or if one population mean is greater or less than the other. Comparing SAT scores between men and women is an example of a two independent sample test. Sampling distribution of the difference of two means independent samples with a population standard deviation known. This is using Welch's T, so again we're using that T distribution. And it says, suppose that the simple random sample of size n1 is taken from a population with an unknown mean mu1 and an unknown standard deviation mu sigma 1. In addition, a simple random sample of n2 is taken from a second population with unknown mean mu2 and unknown standard deviation sigma 2. If the two populations are normally distributed or the sample sizes are significantly large, we're saying larger than 30, then T is equal to, and there's a formula there, and it approximately follows the student T distribution with the smaller one degrees of freedom, where x1 bar is the sample mean and S1 is the sample standard deviation from population 1, and likewise for population 2. There's a box here that we are going to give a star to. The box is testing hypotheses regarding differences of two means with the TI-8384 calculator. We can use this test provided that these criteria are met. So both are simple random samples, the samples are independent, and it either says that they're normally distributed with no outliers, or the sample sizes are going to be large. Step 1 is determine the null and the alternative hypotheses. They can be structured one of three ways. The null is always going to be H1 as mu1 is going to equal to mu2. H1 is going to always be, depending on if it's a two-tailed, left-tailed, or right-tailed test. Step 2 is to determine the level of significance, and this is usually given to you guys for alpha. Step 3, go to stat, test, 2 SAMP T test, so check and change it if it's something different on your calculator. If the data is raw, input the data into L1 and L2 and set frequency 1 equal to frequency 2 equal to 1. If summary stats are known, you need to input in all of these values. Highlight the relationship between mu1 and mu2 in our alternative hypotheses. Select pool to no. Highlight calculate and enter. You get two values as your output that are important to us. T is our test statistic and P is our p-value. It says if the p-value is less than alpha, we reject H0, and then you need to state your conclusion. On the next page, it also discusses confidence intervals for doing the test. So give that a star. Construct a confidence interval for the differences of two means with the TI-8384 calculator. So step 1, stat, test, and for me it was 0, which is 2 SAMP T int. And again, it says exactly what was up above. If you have raw data, enter those into L1 and L2. Set frequency 1 equal to frequency 2 equals 1. If summary stats are known, you need to input in all these numbers. Pool to no, and select your confidence level. This requires us to draw a picture and kind of think about how that confidence level will be set up.